Okay, hello, welcome back to another one of my video log recording sessions. The date is 2025 March 25th, and today I'll be covering the notebook titled Genetic Algorithm Grid Search 340 Items All FX Rev, as in the revised version, with the where I used the metric, which is the average of top 10%, 20% entities in terms of their summed utility values. And also, I also collect the top entity, which I call the head. I also collect the data about the bottom entities, which I call the tails. So in this notebook, I have done this exact same notebook last time, which was titled Genetic Algorithm Grid Search 340 Items All FX, but this is again a new revised version. So all the code up until here is the same, including this one is the same, and it's just that I now have the compute average summed utility function, and I'll be using that. And at the end of each evolution for each procreate function, I also added a few more plots where I indicate where the plateaus are and where I indicate where the peaks are, and I also calculated the size of the dips, the peak minus plateau level, and I also calculated the percentage of the dips, or rather the dip sizes, when compared to the peak or the peaks. So yeah, so for example, if the peak was 1000 and the plateau level is 900, then there's a 10% decrease. The dip size is 10% relative to the peak level. So that's that. I go through with the evolution, which takes about how many? 838 seconds. Really? Okay. Is that really the case? I don't know. Let's just see. Look at the last original one. Maybe I ran this here, but so. Or oh yeah, I've had more population, or maybe a bigger number for the total generation. So so for that we look at the hyperparameters just to make things clear. The population size is 1000, whereas the generations is 500. So whereas here it used to be population size 1000 and generations is 500. Huh. Maybe it was 3000 when I did that. Or it's just that I ran everything for more 5 times. I wonder why. I wonder what changed. It's not supposed to be... It's not supposed to take that long. Supposing that I did this on my laptop, so something is different. Maybe it was more bigger population. Maybe it was more generations. I don't know. We'll see. Let's see that. One thousand. Generations. It is 500. Maybe I ran it here. Yeah, then that would make sense. No, even that wouldn't make sense. Because Google Colab is about 3 times slower, so it should be near 2500, not 2000. Something is off. I don't know what. Okay, I'll find that out someday. But not now. Later. So, these are the hyperparameters for now. Population size 1000 and generations is 500, and we have 40 items. And after running the evolution for 5 times per procreate function, after about 840 seconds, we established that the maximum ever for the top entity is 1135, and these are the plots for all the one each from every procreate function. There's a dip, and these are the but then again, this is the result for the heads, so it doesn't actually represent much. It does represent to some extent, but it doesn't represent much about the characteristics of each procreate function, or the results that come from these different procreate functions. And sorry. And these are the plots. So there is the dip. This bluish line is for Lonely Island, the self-replicate. But there are no dips. But then again, it doesn't peak either. So, but these we have seen before. Kind of. It's just that now the new metric has been applied, and from this plot we can establish that similar behaviors happen, or similar behaviors are shown, as seen. Where is it? Yeah, as seen here. So this plot from the previous one, where the new metric is not being used, the new metric being the average of top n% entities, in this case the top 10%, and this is it. So this one is more volatile, the lines are more volatile, however the behaviors are quite similar. This one looks more volatile because the limit for the y-axis is not 1250, it's 1150, and therefore these lines just seem to oscillate more. If I change it, it will look a lot more like this. Not exactly the same in terms of magnitude for the oscillations, but it will look pretty much the same, I think, or quite similar. And these are the plots for every single procreate function, and for every single iteration per procreate function. And these are the plots for the tails. They're all there, and nothing that unusual. They oscillate, yep. And again, for all the iterations for all the procreate functions. So very messy, very noisy, hard to make sense of it, but we get the gist of it. And now, for the detailed assessment, what I did here is I calculated, or rather I tried to pinpoint by hand the peaks and the plateaus where I can, or rather calculated, and express them on each of the plots, on each plot for each procreate function. So this is the list for the maximum top 10%, maximum value for the average of the top 10%. Yeah, that's the right way to say it. So here we go. And what is this? And this is a way to calculate the plateau. And this is the list, an empty list, and I loop through the result list top 10%, and I calculate the average of the last 100 values, thinking that it would be appropriate for now. It's a makeshift way of doing this. There are better ways of doing this. There would be, and there should be. For example, calculating the gradients until the gradient doesn't change that much as compared to previous gradients. When it becomes close to 0 and stopping there, or just calculating the gradient everywhere and then plotting that. Anyway, but right now this is a makeshift way, as I've stated here, quick and makeshift version of doing this, and these are the values in the plateau list for top 10%. And I'm only taking in one of the iterations, in this case the fourth one, per procreate function. But as you'll see, it does represent the information quite well, so I stuck with it. And so here are the plots for each procreate function. For example, this one is for the lonely procreate, the red line being at 1000 for no reason, I just wanted to highlight that, and the gold line, the maximum ever, which is 1135, and the peak is in, where is it? Where's the peak? Ah, there we go. The peak is in black. So there we go. Black line. And the plateau is in magenta, as you can see here. The dotted dash line, dot dashed or dotted dash or dotted dashed line, whatever. So, and we see here that the dip size is 37.42 and the percentage change is 4.1%. So not that much of a dip, actually not even a dip when compared to others, but yeah, it is what it is anyway for now. And this plot is for the Monopoly Elite Procreate, where the top entity is always chosen as parent 1 and parent 2 is chosen from the top 10%. And as you can see, the peak is being this black line is 945.79 and the plateau is 816. Actually, I did calculate things, at least. I didn't do it by hand, entirely by hand, rather. And the dip size is 129.559 and the percentage change is 13.7, minus 13.7. So it instantly got bigger, but more to see. This plot is for the Monopoly All Procreate, whereas the top entity is always parent 1 and parent 2 is chosen from all the other rest of entities within that generation. So because of that, the peak is 864 as compared to 945, so about 80 difference. Plateau is about 803. Dip size is 660 as opposed to compared to 129, so one half that. And the percentage change dip is 6.9, so around 7%. But these dip size and dip percentage change are smaller compared to this because it didn't peak as high. Yeah. As you can see, the plateau level isn't that different. It's 816 versus 803. So it's only 13 difference. There's a difference of 13 some utility values. However, the peak is different. This one's 864, this one's 945. So again, 80 rather. So when we add the 80 here, it's 140, or it's 129. So not that big of a difference. No. Not huge. So we can say that the dip size and the dip percent in terms of change, the percentage and change are not that big because the peak is not that high. So the third plot, or is it the fourth? Is it 4? Yeah, it's the fourth one. Fourth one is for the oligopoly procreate, where parent 1 and parent 2 are chosen from the top 10% entities, and the peak is at 971, so that's higher than 945 or 912 from here, which is kind of surprising. And the dip size is the plateau is at 815, the dip size is 156, and the dip percentage is 16%. So the percentage change is similar to this one. It's just that the peak is higher when you use oligopoly procreate. The fifth one is the favoring high procreate, and the peak is at 918, plateau is at 816, dip size is 102, and dip percentage is 11%. So fair enough. I mean, it's not as good as oligopoly procreate, but it's better than what is it? Monopoly winner takes all. Monopoly winner takes all. Did I cover that? Yep, I did. So the sixth one, is it the sixth one? Yeah, the sixth one is this proportional procreate, and the peak is at 811, so very kind of lower than the other ones, or rather the lowest one so far, I think. And the plateau is at 783, the dip size is 28, and dip percentage is 3.5% only. But it's not that advisable, I guess. The entities are not evolving to their fullest or near fullest potential, and therefore there isn't much of a dip. The seventh one, numbered 6, but again it's from 0 to 9, is less favoring high procreate. The peak is 899 or almost 900, plateau is 807, dip size is 92, dip percentage is 10.29%. So again, everything's lower and smaller than the favoring highs here. The eighth one is opposites procreate, where parent 1 and parent 2 are supposed to be very different from one another, and the result of that is the peak is at 808, plateau is at 791, dip size is 16, and dip percentage is 2.09%. Again, the dips are smaller than when we used the proportional procreate, and the overall level is also lower here, so it's not I don't think it would be a good advice to use this one all the time. It will come in handy, you know, under some certain circumstances, but not all the time, because the entities are not evolving again their to their fullest potential or near fullest potential. The ninth one is birds of feather procreate, where parent 1 and parent 2 are entities that are very similar to one another, and that also gives us somewhat similar results, because the peak is at 808, plateau is at 787, dip size is 20, dip percentage is 2.58. So very similar to this, which is this is quite interesting, because it seems that whether you let entities that are very similar to one another procreate, or whether you let entities that are very different from one another procreate, they will produce almost the same results when it comes to the averages of top 10% or top something percent entities in terms of summed utility values. So this is the 10th one, the last one for now, the last one of the procreate functions for now. Pure chance, so totally random selection, where parent 1 and parent 2 are just selected at random. Yeah. And the peak is at 805, plateau is at 788, dip size is 17, and dip percentage change, dip percentage in change is 2.15%. So again, kind of very similar to these two previous ones. But however, we would like to I already had the peak list. Do I not have the peak list? Yep. So what I did here is I created 4 lists containing peak list, plateau, peaks, plateaus, dip sizes, and dip percentages, respectively, and loop them through so that I can create this. It's not much, but here I have a... Sorry, excuse me. Sorry, I needed to cough. Here I have a plot, a scatter plot, where I can see the dip and where I can see the peak or peaks and the plateaus and the dip sizes in one view, and the next plot is for the percentage, dip percentage. So this is the first one, second one, third one, all the way to the 10th one, the last one. And as we've seen, the last 3 procreate functions are very similar, and also in terms of dip size and dip percentages as well. And the biggest dips are created by 1, 2, 3, 4, the 4th procreate function, which is the oligopoly, and maybe the second biggest is the second one, the monopoly, which are 2 very similar procreate functions, because monopoly elitis, parent 1 is always fixed to be the top entity, the head, and the second one and parent 2 is selected at random from the top 10%, from rest of the top 10% entities, or maybe was it top 15 or 10? Let me just check. Yeah, top 10%. And whereas the oligopoly, parent 1 and 2 are chosen from the top, was it top 10%? Yeah, from the top 10%. So they share a lot they share a lot of common factors. And it seems that But somehow it seems that fixing parent 1 to be the top entity performs in some way or kind of less well than selecting parent 1 and 2 from the top 10% entities. So let me rephrase that. Selecting parent 1 and 2 randomly from top 10% entities has a higher peak level than when selecting parent 1 always when selecting the top entity always as the parent 1 and selecting parent 2 from the rest of the top 10% entities, and hence the bigger dip size and the higher dip percentage. So that's interesting. And the Lonely Island, the self-replication, gives us a very low dip percentage, and smaller dip sizes, while having values that are kind of on the higher half or the higher end. Yeah. And what is this? 10, 9, 8, 7, 6. The sixth one. Proportional also gives us kind of mediocre. So it will have its use, but not all the time. And favoring highs, that's the fifth one. 1, 2, 3, 4, 5. Favoring highs also performs decent. Performs decently, with somewhat of a smaller or lower dip percentage or dip sizes, smaller than oligopoly or monopoly elitist. So it's not that bad. The seventh one is opposites attract. No, that's the eighth one. The seventh one is less favoring highs. So this one, very similar to favoring highs. So again, just to add on to what I've just said, the last three, which are the opposites attract, birds of feather, pure chance, they're very similar in terms of their metrics after the evolution is complete or has been processed or progressed or whatever has finished. However, this one, the fifth one, which is 1, 2, 3, 4, 5, proportional, is also kind of very similar. So these four produce almost or very similar results. So maybe I can use these to minimize or control the dip sizes, or I can just use the self-replicate. But the downside of using self-replicate, the Lonely Island procreate function, is that it feels like cheating. It doesn't feel organic. So that's the only reason, or that's the only qualm I have about that. Yeah, so that's about it. Thanks for watching. I didn't even go through the code and it took 30 minutes. Wow. Okay. Bye.